This is part 3 to section 4.5 videos, and this part I'm just keep going through more examples. So I'll do these 4 examples. 3 of them involve trig. That way you get some integration examples, u-substitution involving trig functions. All right, number 23 has the integral of x squared divided by 1 plus x cubed squared dx. The more complicated stuff is the 1 plus x cubed portion. And I know that the derivative of x cubed is 3x squared, so it involves something with x squared. Now, might help to write it like this. And then put x squared dx. So I'll let u be the stuff in parentheses, the 1 plus x cubed. Taking the derivative of 1 plus x cubed, well, the derivative of 1 is 0. Derivative of x cubed is 3x squared. And then I latch on the dx, and notice in the integral, I have just x squared, whereas I have 3x squared, so I need to multiply both sides by a third. So if I multiply both sides by a third, I'll get 1/3 du equal to x squared dx, because the 3 and 1/3 cancel each other out. Right, so I can substitute in the 1/3 du for the x squared dx. Now I've got to go ahead and substitute, so I'll have 1 over, and then u is the 1 plus x cubed portion, so it'll be u, and then squared. And then x squared dx is 1/3 du. All right, so now I just integrate this, and I'll factor out the 1/3. So you have u squared in the denominator. If I want to make use of the power rule, I can write u squared, or 1 over u squared as u to the negative 2, using exponent rules. And now I can integrate. So it'll be 1/3 times, and it's u to the negative 2 plus 1 divided by that same thing, negative 2 plus 1. All right, negative 2 plus 1, that's negative 1. So I basically have 1/3 times u to the negative 1 over negative 1, and then plus c. Well, that's negative 1/3. And since that's a negative exponent, I would make it positive by bringing u to the denominator. So that way it'll be 1 over, or sorry, because the negative, so it'll be negative 1/3. Negative, and then 1 over 3 u, and then plus c. So that way I put the u in the denominator, so it becomes a positive 1 exponent. Now we back substitute. So u was 1 plus x cubed, so this will be equal to negative 1 over 3 times, and then parentheses 1 plus x cubed, and then plus c. All right, so that's going to be the answer. And again, so I'll let u be the more complicated stuff, the 1 plus x cubed, and then the derivative of 1 plus x cubed is 3x squared. And then I have the dx so that I can substitute it in for x squared dx, but I had to multiply both sides by 1/3. So that way I'll have 1/3 du is equal to x squared dx. So I get rid of the 3, and I do 1/3 times 3. Then I just substitute everything in, and then integrate, and then back substitute. All right, so now I'll do some trig examples. So number 39. So it's pi times sine of pi x and dx. And if you want, you can put the parentheses around the pi x to reinforce that's what you're taking the sine of. That's the argument of the sine function. Now we know from integration rules, if you integrate sine, you get negative cosine. So derivative of sine is positive cosine. When you integrate sine, you get negative cosine. So what I'm going to do is, if I let u be what's inside of the parentheses, pi times x, then I take the derivative. So du is pi times 1, which is just pi, because the derivative of x is 1. And then I attach the dx. And I notice I have a pi and a dx. So I can go ahead and start substituting stuff in. Maybe it might help to write it first sine and then pi x times pi dx. So u is the pi x part. That's sine of u, and then pi dx is du. And we know sine becomes negative cosine. And then I just back substitute what u was. And u was pi times x. So this is negative cosine pi x and then plus c. All right, and that's how I do that problem. The next one is number 43. All right, so 43's got 1 over theta squared, and then cosine, and it's 1 over theta d theta. Now the 1 over theta part is what you're taking cosine of, so I'm just going to go ahead and put those parentheses. Now, just like before, where I let u be the stuff in parentheses, I'm going to do the same thing here. But before I do that, I'm going to rewrite the expression so that I have cosine of 1 over theta and then times 1 over theta squared d theta. Now I want to let u be 1 over theta. What is 1 over theta? That's the same thing as theta to the negative 1. So really I'm letting u be equal to theta to the negative 1. So it might be beneficial to just go ahead and write this as cosine of theta to the negative 1. And I can rewrite 1 over theta squared as theta to the negative 2. because when I take the derivative of theta to the negative 1, so du, that's going to be drop down the exponent, negative 1 times theta to the negative 1 minus 1, which is negative 2. And then I attach the d theta. Now notice I don't have the negative sign in the integral, I just only have theta to the negative 2. So I need to multiply both sides by negative 1, or divide by negative 1, either way. And all that's going to do is bring the negative on the left side with, so it'll be negative du equal to theta to the negative 2 d theta. So the whole thing that's negative du, that's what I'm plugging into the integral, substituting in for this, and then this is just u. So I'll have the integral of cosine of u, and then instead of theta negative 2 d theta, that's negative du. I'll factor out the negative in front of cosine, or in front of the integral, so it'll be negative, and then cosine of u du. So for integrating cosine, it becomes positive sine. All right, it's opposite when you take the derivative, or sorry, sign change when you take the derivative. If you take the derivative of cosine, it's negative sine, but integrating it becomes positive sine. So this becomes negative sine of u, and then plus c. And then I just back substitute. That's going to be u is theta to the negative 1. Well, theta to the negative 1 is the same thing as 1 over theta. So I'm just going to go ahead and write it as 1 over theta. All right, so that's going to be the answer for this one. All right, and this number 45, so they have sine of 2x, cosine of 2x, and then dx. Now I'm going to say there's multiple ways to do this problem. There's 3 possible answers, or there might be more, but there's 3 possible answers I know. Depending which route you take. Now the previous examples I was letting u be what's inside of, like the cosine was 1 over theta, I let u be 1 over theta, and then for sine of pi x, I let u be the pi x part. Now for this one, I mean technically, so you can put the parentheses around these. If I let u be what's inside the parentheses, 2x, then du would be 2. And that wouldn't really help us much because I couldn't substitute it in for anything. So what you could try, I'll show in three options. Option 1, I could let u be maybe sine of 2x. Then the derivative of sine is cosine, but I'll use chain rule. So this will be du is equal to, so derivative of sine is cosine, so that's cosine of 2x, but then you have to take the derivative of 2x, which is 2. So it'll be times 2, and then dx, so then it's 2 cosine 2x dx. All right, and this was, so I have this to be u, and that is du. So this is using chain rule. So that turns into cosine u times u prime. In this case, for sine of 2x, it comes into cosine of 2x times u prime. U in this case is 2x, so that's where I get times 2 from. So that's one of my options, is I could let u be sine of 2x, and then du is going to become 2 cosine 2x dx. Now notice in the problem, I have just cosine of 2x. So I would have to divide both sides by 2, or multiply by a half. Then I would have 1/2 du is equal to cosine of 2x dx. All right, that's what I'll go with for the first option. Now, option 2, the second option, instead of letting u be sine of 2x, you could let u be cosine of 2x. Well, derivative of cosine is negative sine, but since there's a 2 times x in the argument of the cosine, you have to do chain rule. So du will become, so derivative of cosine is negative sine, so it's negative sine of 2x, and then derivative of 2x is 2, would be times 2, and then dx. So du would be negative 2 sine of 2x. And in the problem, it just has sine of 2x. It doesn't have that negative 2. So you would multiply both sides by negative 1/2, or divide by negative 2. So then I'd have negative 1/2 du is equal to sine of 2x dx. All right, that would be, this would be using the second option. That's what you sub in for sine of 2x dx, and then u is cosine of 2x. Now the third option is to use a trig identity to rewrite the problem. So you would rewrite the integral using a trig identity. So there's a double angle identity for sine. So if you have sine of 2 theta, that's equal to 2 sine theta cosine theta. In the integral, it was, I'll just go ahead and write it over again. So the problem had sine of 2x cosine of 2x. So it's got that structure of sine times something, or sine of something, then times cosine of something. But if you let theta be the two in the spot for 2x, so wherever there's theta right here, you put 2x. And that would give you, so instead of sine of 2 times theta, that's sine of 2 times 2x. So that's sine of 4 theta. Now I'm going to go ahead and put it in parentheses. Is equal to 2 sine of 2x and then cosine 2x. And this should be x. So I'm doing 2 times. I'm letting theta be 2x. So 2 theta would be 2 times 2x, which is 4x. So then I would have to bring the 2 over by dividing both sides by 2, or multiplying by a half. So then you have 1/2 sine of 4x equal to sine of 2x cosine of 2x. And then you could let this be in the spot of this whole thing. So that would make the problem turn into the integral of 1/2 of sine 4x or sorry, 4x dx, theta. And then you just go from here. And I would do a u sub for the 4x. All right, so those are the 3 options we could go with. So now I'm going to work it out with each option so it show which answer you have, the 3 different answers. All right, so option 1 is letting sine be u. All right, so this is option 1. I'll let u be sine of 2x. So then derivative to use cosine, derivative of sine is cosine, so it'd be cosine of 2x times 2 by chain rule. So we said that's du is equal to 2 cosine 2x dx. But we have just cosine 2x in the integral, so we would divide both sides by 2 or multiply by a half, which would give us 1/2 du is equal to cosine of 2x dx. All right, so that's going to plug in right there. And then this whole thing is u. So that's going to give me the integral of u. And then cosine of 2x dx is 1/2 du. All right, then you factor out the 1/2. Then you're just integrating u. And that's just using regular power rules. So it'd be 1/2 times e to the 1 plus 1 divided by 1 plus 1, and then plus c. So that's 1/4 u squared plus c. and then I back substitute what u was. U was sine of 2x. So it'd be sine squared of 2x. Right, and that's the answer going with the first option. So I'm saying that's a possible answer. Now option 2. That was letting u be cosine this time. And then du turns into -2 sine of 2x. Right, because earlier we had 2 cosine 2x, but for this one, we take the derivative of cosine, it turns into negative sine, so it'd be -2 sine of 2x, which then you would make this -1/2 du. You put a sine of 2x dx. So for this, I can substitute the -1/2 du, and then the cosine of 2x part, that's what I'd use for u. So if it helps, you could write it so that cosine's listed first. Because multiplication is commutative, and then sine of 2x dx, and then substitute what cosine is u, and then sine of 2x dx is -1/2 du. All right, and so hopefully that makes sense. Then you factor out the -1/2, and then you're integrating just u. Well, that turns into -1/2 times u to the 1 plus 1 over 1 plus 1, then plus c. So that's -1/4 u squared plus c. But here u is different, right? This time u is cosine of 2x. So this would be -1/4 cosine squared of 2x plus c. So that's another possible answer. All right, so the first option gave us 1/4 sine squared of 2x plus c. The second option gives -1/4 cosine squared of 2x plus c. So one of them is just negative and it's the cosine squared, whereas the other one's positive and sine squared. The third option is the most unique one. Okay, so we established earlier when we used the double angle identity when we had, so the problem had sine of 2x, cosine of 2x, and I said to let theta go in the spot for 2x. So then sine of 2 times 2x is equal to 2 sine of 2x cosine of 2x. And I just said that was sine of 4x. And then 2 sine of 2x cosine of 2x. The problem only has sine of 2x cosine of 2x, so I said to divide by 2. So you get 1/2 sine of 4x. All right, that's what I said we could use for the third option. So the original problem was the integral of sine of 2x cosine of 2x dx. Now I use a double angle identity and rewrote it so that now it turns into 1/2, or the integral of 1/2 sine of 4x. And so that way it's only one trig function. Now this way it's more complicated because you had to remember a trig identity, double angle identity. And now I would just integrate. I would factor out the 1/2 first. So if you 1/2, and then integrating sine of 4x dx. I'm going to let u be the portion that's in the parentheses. So u is going to be 4x. So du is going to be 4 times 1 is 4, so it'd be 4, and then attach the dx. Here we just have only dx, so I would multiply by a 4th. So that'll be 1/4 du is equal to dx. That's what I'll plug in for that spot. So this will equal 1/2, and then integral, and now it's sine of u. And then instead of dx, it's 1/4 du. All right, then I'd factor out the 1/4 and times it by 1/2 to get 1/8. And then integrating to sine. Well, integrating sine becomes negative cosine. So this will be 1/8 times negative cosine of u, and plus c. And then I just back substitute u as 4x. And so bringing out the negative in the front, so it's negative 1/8 cosine of 4x, and then plus c. So that just doesn't have any powers to it for the trig function, it's just regular cosine. So depending on which path you go, right, dictates which of the three answers you'll have. So the three answers were 1/4 sine squared of 2x plus c, and that was letting u be sine of 2x. The second answer was negative 1/4 cosine squared of 2x, and that was letting u be cosine of 2x. The third option is the more complicated one, but you'll get your answer to be negative 1/8 cosine of 4x plus c. There's no power, whereas the other two had exponents of 2. But the third option, you had to use a double angle identity. All right, so that's where I'll stop it with this video.